Hi everyone. In today's video, I'm going to go through the distributed neural network cross-validation in DATAVIEW CUDA workflow on GPU cluster. This is a final report, and the term project is working by me and Ziyun Xiao. We're targeting to distribute a 5-fold cross-validation on GPU cluster in DATAVIEW in order to pick up the best architecture from 3 different neural network architectures. For example, for the first architecture, we can have 4 layers. The second architecture can with 10 layers, and third architecture can be with 5 layers. In order to pick up the best architecture for a specific dataset, we can use a k-fold cross-validation. Here is a demo on how k-fold cross-validation works. If k equals 8, that means we're going to split the dataset into 8 parts. For every fold, we're going to use a single different parts for the testing purpose, and the other sets will be using for training purpose. So for every fold, we're going to use different dataset for training and testing, so that help us to working on a small dataset and to get more insight from the training and testing with a k-fold cross-validation to pick up the best model. So here is a GPU cluster we're going to use in the DATAVIEW system. Basically, we have 6 nodes in the GPU cluster for now, but this is very scalable, and in the future we can add more cluster nodes. And here basically we consist of 2 types of machines. First one is a Jetson Nano, and the second one is Jetson Xavier. And we have 4 nodes of Jetson Nano and 2 nodes of Jetson Xavier. Jetson Xavier is a bit more powerful than the Jetson nodes, which consists of more CUDA cores and TensorFlow cores than the Nano. So based on different workflows or workloads, we can use different machines. So this is something we can utilize by having a heterogeneous cluster GPU. So here is the challenges we proposed when we have this idea. And first one, we have to set up proper GPU cluster environment to conduct the parallel training on neural network, and this has been done in the part 1. And second, we have to dispatch the proper JSON format specification from DATAVIEW to the nodes in the cluster in order to carry out the training and testing purpose. And also we have to implement necessary message parsing among the nodes in order to carry out the k-fold cross-validation, or we need to distribute the workloads to the slave nodes and reduce the result to the master node. So here is a GPU cluster setup. We have installed the Ubuntu 18.04.4 LTS operating system on each one of them. We also set up the static IP on each one of them, enable SSH among the nodes. We also enable the MPI among the nodes. So I will have a short live demo on how our project is working. Basically, this will cover following points. First, we're going to demo how to construct a neural network workflow, which is also called NN workflow in DATAVIEW from Eclipse. And we will also demo how to execute an workflow on GPU cluster. And finally, we're going to monitor the map and reduce process from Eclipse and GPU cluster terminals. So if we take a look at Eclipse, we're going to have idea how this NN workflow look like. So here is one example of the NN workflow, and this workflow will extend an NN workflow class. If we take a look at this NN workflow class, which extend the base class workflow, so that means we are able to utilize whatever inside the workflow class. So this is a good thing. We can utilize or inherit all the method from the workflow base class. And here is how we can construct an workflow. Basically, we'll specify the same thing: the name, description, and input, output, the input file and output file, And we also have the design method. Here we have an array of the n tasks, and this n task is also extend the task-based class. So that means we can inherit all the method from the task. Basically, n task is a task as well. So here we have an array of n tasks. This one contains 4 layers. We have one linear layer, relu layer, linear layer, and sigmoid layer. So for the linear layer, we can specify how many neurons input and how many neurons output. So here, for example, like this layer, we have 5 neurons as input and 3 neurons as output. And finally, we're going to feed this array of n tasks into a sequential function call. And this sequential function call basically will help us to add edges between these tasks, this n task that construct a n workflow. So after we have this n workflow, we can call that from n test.java. So this is a main entry where we can trigger or we can trigger any n workflows with a specific n trainer. So here we can see we choose the n workflow 2, which is we just saw. We just walk through, and after that we can use the design method to get the workflow. And here we can also draw this workflow out, and after that we can feed this workflow into the one of the trainer, and this trainer is called workflow trainer cross validation on GPU cluster. And we also specify the file location. Inside we can call the train method within this trainer. So after that we can specify the eclipse time on the execution, and finally we can print out its execution time to indicate the execution is done. So if we take a look at the terminals of the GPU cluster, so you can see from here I have 4 nodes open, and as well as a 5th node, because we're going to have a 5-fold cross validation. And you can see from the host name, this is JSON nodes 1, and JSON nodes 2, JSON node 3, and JSON node 4, as well as the JSON nodes 5. They all with different IP, and of course they're static IP. So if we change them into the GPU monitoring, and if we run the cross validation from the Eclipse, we're going to see this one is a architecture we're going to run on different nodes. So you can see it has been executed, and you can see from each node it's quickly executed what had been triggered from the master node. So here the master node is node 1. It will map the workloads into 2, 3, 4, and 5 work nodes, and then reduce the result into the master node and send back to the Eclipse. So if we take a look at the terminal from the Eclipse, we're able to see every node is going to prepare the data. Of course, they're going to have a same split, but they were basically working on different data set. That means every node, every fold will have a different data set for testing and training. So this is a purpose. If we take a look at the output, we're going to see that for every 100 epochs, there will be 5 records. So these 5 records will be from 5 nodes. You can see they're having the different cost. So that means they're working on a different data set. So this looks good. After that, we're going to have the average accuracy of the 5-fold cross validation. So we can do the same thing for the other architectures on the same data set in order to pick up the best one. But for now, I think the accuracy is not so good. We're currently working on how to improve the accuracy, and based on maybe we can develop or implement better optimizer or further debugging the code. So I think that's it for now, and thank you so much for watching this video. Hope this is helpful. Until next time, happy coding.